Today we shall see 9 topics regarding algorithm and flowchart, but with example. How to use flowcharts to represent algorithms. Now that we have the definition of algorithm and flowchart, how do we use a flowchart to represent an algorithm? Algorithm and flowchart are two types of tools to explain the process of a program. We have seen in last lecture that algorithm is nothing but to write a logical step-by-step method to solve the problem. In other words, it could be a procedure for solving problems. In order to solve a mathematical or computer problem, this is first step of procedure. An algorithm includes calculations, reasoning, and data processing. Algorithms can be presented by natural languages, pseudocode and flowcharts, etc. We have also seen a flowchart is the graphical or pictorial representation of an algorithm with the help of different symbols, shapes, and arrows in order to demonstrate a process or a program. With algorithms, we can easily understand a program. The main purpose of the flowchart is to analyze different processes. Several standard graphics are applied in a flowchart. Like we use a ellipse shape for start and end. We use a rhombus for input and output. We use a rectangle for process or instruction. We use a kite or diamond shape for decision making. And we use connectors and arrows in the flowchart. The graphics with the help of these symbols represent different parts of a flowchart. The process in a flowchart can be expressed through boxes and arrows with different sizes and colors. In a flowchart, we can easily highlight a certain element and the relationship between each part. Algorithms and flowcharts are two different tools used for creating new programs, especially in computer programming. Algorithm is step-by-step analysis of the process, while a flowchart explains the steps of a program in a graphical way. Then you might ask, then what is the difference between algorithm and flowchart? If you compare a flowchart to a movie, then an algorithm is the story of that movie. In other words, an algorithm is the core of a flowchart. Actually, in the field of computer programming, there are many differences between algorithm and flowchart regarding various aspects, such as the accuracy, the way they display, and the way people feel about them. Let us see this difference in the form of a table which differentiates between algorithm and flowchart. Algorithm is a procedure for solving problems, whereas flowchart, it is a graphic representation of a process. Algorithm is the process shown in step-by-step instruction, whereas the process is shown in flowchart. The process is shown in block-by-block information diagram. Algorithm is complex and difficult to understand, whereas flowchart is intuitive and easy to understand. Algorithm is convenient to debug errors. Flowchart is hard to debug errors. Algorithm solution is showcased in natural language. Chart, the solution is showcased in pictorial format. It is somewhat easier to solve complex problem with algorithm. It is hard to solve complex problem with flowchart. In algorithm, it costs more time to create an algorithm. It costs less time to create a flowchart. What are the different types of algorithm? It is not surprising that algorithms are widely used in computer programming. However, it can be applied to solving problems mathematically and even in everyday life. Now let's see. So then here come a question. How many types of algorithms are there? According to Dr. Christoph, a computer scientist working at Research Institute for Simcosan Computation, RISC, in Austria, has surveyed about voting for the important types of algorithm. As a result, he had listed 32 important algorithms in computer science. Despite the complexity of algorithm, which we are going to see next, we can generally divide algorithms into 6 fundamental types based on their function. So these types of algorithm, these 6 types are: first, recursive algorithm. It refers to a way to solve problems by repeatedly breaking down the problem into sub-problems of the same kind. The classic example of using recursive algorithm to solve problem is the Tower of Hanoi. Second, divide and conquer. Traditionally, the divide and conquer algorithm consists of two parts. One, breaking down a problem into some smaller independent subproblems of the same type. Second, finding the solution of the original problem after solving the smaller problems separately. Third is dynamic programming algorithm. It is developed by Richard Bellman in 1950s, and the dynamic programming algorithm is generally used for optimization problems. In this type of algorithm, past results are collected for future use. Similar to divide and conquer algorithm, the dynamic programming algorithm simplifies a complex problem by breaking it down into some simple subproblems. However, the biggest difference between them is that the latter requires overlapping subproblems while the former doesn't need to. Fourth is the greedy algorithm. This is another way of solving optimization problems. It refers to always finding the best solution in every step instead of considering the overall optimality. This is to say, what he has done is just a local optimum. Due to the limitations of the greedy algorithm, it has to be noted that the key to choosing a greedy algorithm is whether to consider any consequences in the future. Fifth is the brute force algorithm. The brute force algorithm is simple and straightforward solution to the problem, normally based on the description of the problem and the definition of the concept involved. You can also use just do it to describe the strategy of brute force. In short, a brute force algorithm is considered as one of the simplest algorithms which iterates all possibilities and ends up with a satisfactory solution. Sixth is backtracking algorithm. Based on a depth-first recursive search, the backtracking algorithm focusing on finding the solution to the problem during the enumeration-like searching process. When it cannot satisfy the condition, it will return backtracking and tries another path. It is suitable for solving large and complicated problems, which gains the reputation of the general solution method. One of the most famous backtracking algorithm example is the 8 queens puzzle. Or if you happen to play chess in your family, that could be also example of backtracking algorithm. Now we shall take an example and jot down the algorithm and see how we can draw the flow chart for this particular real life problem. Because due to COVID-19 situation, we have seen the screening tools nowadays. So let's take an example of coronavirus screening using thermal imaging. See it in video first. The video is divided into two parts. Carefully watch the video and tell me for which part you can jot down the algorithm or for which part you can draw a flowchart. So let's start the video.
So, how does a thermal camera work? To explain this better, we have set up a little experiment here. So we have a couple of coffee mugs. One contains hot water, one contains cold water. And we have a FLIR thermal camera on the other side pointed at those coffee mugs. What we see here is the thermal camera image coming from the software running on a PC that we cannot see in the scene right now. And on the left side we have an orange glow which indicates hot temperature, and on the right side we can barely make out the cold cup, and we have drawn a couple of regions of interest around these cups, and we can see here on the software it actually measures the maximum temperature from the hot cup to be about 170 degrees Fahrenheit, and on the cold side we see about 63. So now that we understand how a thermal camera works, let's see how we can apply this to measuring skin temperature. When the immune system detects an infection, it usually kicks into high gear and raises the core body temperature. Based on recent research, the best location in the face to detect the core body temperature is the inner tear duct. However, one problem that occurs is when somebody wears glasses, because the thermal camera cannot see through glass, so the glasses occlude the important temperature locations in the face. Another important fact to point out is that the thermal camera cannot detect a particular virus. It can merely tell you whether you have an elevated body temperature. For that to work well, you need a very high resolution thermal image across somebody's face.
There are lots of temperature screening tools on the market today, ranging from simple handheld infrared thermometers to automated systems capable of scanning large groups at the same time. but which one is right for you? Let's take a look at a few different options. The most budget-friendly solution is a non-contact thermometer like the X-Tech IR200. This tool is an FDA-certified non-contact forehead thermometer designed to measure temperature by scanning the forehead. Scans can be done quickly on one person at a time. The IR200 features an adjustable alarm. Simply tell it the temperature you want to be alerted for, and it will provide a visual and audible signal when the threshold has been crossed. The IR200 is a non-contact tool, but optimum measurement distance is between 1.9 and 5.9 inches. That means users will still need to be in close proximity to obtain an accurate reading. The next step up from non-contact thermometers is a system like SeqScan. SeqScan uses thermal imaging to screen one person at a time from a distance of 5 feet so you can maintain social distancing. Setup is quick and no special training is required. Each scan takes just 1 second so your lines move quickly. Scan has just 2 main parts: a thermal camera and a heat source calibrated to healthy human skin temperature. To set up, simply measure 5 feet between the camera and heat source tripods, then connect the camera to a PC. When someone stands next to the heat source, the camera measures their skin temperature against the known reference temperature. Based on your temperature threshold setting, the system will give a pass or fail signal. It's that easy. Another step up from SeqScan is a group screening tool like the Flowchart 226B. Using an AI facial detection module, this system can scan multiple people at once very quickly. Best of all, it can do it from up to 10.5 feet away, so everyone stays at a safe distance. As subjects enter the field of view, the 226B system automatically locks onto their faces and takes temperature readings. Based on the alarm setting, the system will provide a pass or fail signal. When its alarm threshold is exceeded, it will automatically take a picture to identify subjects for further screening. The 226B is also designed to prevent false positives. It will automatically ignore non-facial sources of heat, such as a hot coffee or a hot tea. It will also adjust for ambient temperature changes between day and night to maintain accuracy in all conditions. Beyond this, it is also possible to use select thermal imaging cameras from FLIR for elevated body temperature screening. FLIR is one of the biggest names in thermal imaging and offers several cameras certified by the US Food and Drug Administration for this task. FLIR cameras feature a high resolution, making it possible to measure temperature at very small points. This enables precise measurement of the tear duct area, which experts have confirmed has a correlation to body core temperature. A built-in screening mode will alert personnel when an alarm threshold has been met. FLIR offers numerous cameras, including the EXX series and the T series, which fall into this range. While these cameras are not cheap, they are extremely powerful and versatile tools. If you need to do any building inspections or equipment surveys, these tools will excel here as well. With a thermal camera, measurements can be taken from several feet away so you can maintain social distancing. You can only screen one person at a time, but each screening takes about 1 second so lines keep moving. All these cameras also include alarm thresholds which can be set up to alert you as soon as your baseline temperature is exceeded. It's important to keep in mind that the items in this video can only measure temperature. They cannot specifically detect or diagnose COVID-19 or any other disease.
So friends, I hope you have enjoyed this video lecture and even the animation which has been shown here. In next lecture, we shall see how to consider the same example and draw the flowchart and algorithm with the help of some tools.